Good evening, everyone, and welcome to the Real Science Exchange, the pubcast where leading scientists and industry professionals meet over a few drinks to discuss the latest ideas and trends in animal nutrition. And we're back here for another episode of the Journal Club with Dr. Bill Weiss, Emeritus Professor from The Ohio State University. Bill, welcome once again for another exciting rendition of the Journal Club. Why don't you start off, Bill, by introducing the guest that you brought with you tonight, and maybe just a little bit about the the paper that she's brought for us.
Okay, Scott, good to be back. The guest I invited was Dr. Helene Lapierre, who I got to know very, very well during several years at working on NASEM. And she brought a guest who I'll let her introduce because she knows her better. But the paper is going to be on lactation performance effects of supplemental histidine in dairy cows, a meta-analysis. So, Helene, if you could just introduce the person you brought, then we'll get into the paper. And welcome to the podcast.
Well, thanks, Bill. And actually, I thought that Susanna had to be on board because she's the one who wrote that paper, right? So, Dr. Susanna Räisänen, she's from Finland, and she did her Ph.D. with Alex Christoph at Penn State University. And then she went back for a beginning of postdoc in Finland, and then moved to Zurich, and now she is currently working in Zurich. Still interested in amino acid and protein nutrition in the dairy cow, right, Susanna?
Yes, very much so. Thank you for the introduction, and thank you for inviting me on the podcast as well. I'm very excited to talk about this topic of histidine. This was also a large part of my PhD that I did with Dr. Christoph at Penn State. So I'm excited to share the results of our meta-analysis with you.
Good to have you. I forgot to mention this is published in Journal Dairy Science this year. I don't have the month, but quite recently. I guess if you could just start, I don't know which one you want to address it, but with meta-analysis, we always want to know how many studies went into the analysis and just a little bit of the background of the data you used for the meta-analysis.
Bill, before we get started, if you don't mind, I kind of just wanted to introduce my co-host once again. It's going to be Dr. Clay Zimmerman. And you might notice, for those of you that's watching at home on YouTube, that Clay and I are side by side, not just on the screen, but literally here physically side by side. And we are here in a conference room at our corporate headquarters in Montvale, New Jersey. So I just wanted to kind of point that out. Also want to thank Helena and Suzanne for joining us. Suzanne, this is not your first time to the pub, so welcome back. Appreciate having you here. So go ahead, Bill. Why don't you just start in then with your introductions?
No problem. I guess, again, if you could just give us a little brief background of the data used for the meta-analysis without going into too much statistical detail.
New research is changing everything we thought we knew about choline's impact on the cow and her calf, and top scientists have a lot to say about it. They are presenting new research that supports choline as a required nutrient to optimize milk production, choline as a required nutrient to support a healthy transition, choline as a required nutrient to improve calf health and growth, and choline as a required nutrient to increase colostrum quantity. This new research is solidifying choline's role as a required nutrient for essentially every cow, regardless of health status, milk production level, or body condition score. Learn more about the science that is changing the game and the choline source that is making it happen. Reassure precision-release choline from Balchem. Visit balchem.com/scientistsay to learn more.
Sure, maybe I can take this, Ellen. So this meta-analysis, we included a total of 17 different studies published between 1999 and 2022. So from some time ago until very recent publications investigating supplemental histidine for dairy cows, lactating dairy cows. And then in some of the studies, there were different combinations of treatments. So we then were able to divide them, some publications, into sub-studies. So in total, we had 22 different kind of studies totally included. And then one important point was for us to divide also the type of supplemental histidine used in different studies. So there were studies that had different forms of infused histidine, but then also a lot of the studies also included the studies we did at Penn State, used rumen-protected histidine. And we actually, as we get into the results, we saw some significant differences between the type of supplemental histidine. And then another point to make about the studies included is also the basal diet. So we had both corn silage-based diets, and those were also included the rumen-protected histidine in most cases. And then most of the infusion studies were actually done with grass silage-based diet. So there were a few confounding factors. I think is something that hopefully in future we can continue these animal studies to investigate also different basal diets with rumen-protected histidine. But that was kind of the data set we had available.
And there was a wide range of inclusion rates or supplementation rates of histidine with the different studies, quite a wide range of them.
Yeah, for sure. Yes. And then also this one important point is also the level of histidine in the basal diet itself was also quite different. So that also expanded the range of different doses as well.
And I thought one other important thing is, at least most of them, it may have been all of them, but you made a comment in the paper that supplemental RP, methionine, and lysine was fed maybe to all of them. I can't remember. So that likely we're not limiting in these studies.
Exactly. Yes, and we made the point to include only studies where everything else was the same within the study. So only the additional histidine was different between the treatments. So that was an important factor as well. And then, most of the studies included either rumen-protected lysine and methionine, or a lot of the infusion studies then included other amino acids as well.
Okay. And then briefly on what all, we'll get into the details, but what all was measured, or what were the primary response variables?
So we looked at all the important lactational performance parameters. So first trimatter intake, and then milk production, energy corrected milk, and milk composition, and also milk component yields. And then we also calculated efficiency of utilization of histidine, including, and then also for all the other amino acids that were supplied to the cow from the diets. We also then calculated the efficiency of marginal recovery of histidine. We can talk about it a little bit later as well. And then another important factor that we looked into was the histidine supply in relation to energy supply as well, and the interaction there, and how that affects the efficiency of utilization. So those were the major factors we included.
Maybe just to step back once, just why we were interested in histidine, why we all begin that story working on histidine. It's like years ago when we began to have a little bit more information or more recommendation for lysine and methionine. All the different approaches, they were suggesting fairly similar supply of lysine and methionine that were at that time recommended based on the proportion relative to NP supply. But for histidine, depending on the different studies that were conducted, the proportion did vary for the recommendations between like less than 2 to almost 4%. So we decided at that time that we should really begin to have a closer look at histidine, because previously most of the work has been focused on lysine and methionine. So that's where we began to work on histidine, and then we made like a very focused study. And after that, Susanna just took over the little review that was made at the end of this study, just to have like a broader perspective with the new studies that she added as well when she was doing her Ph.D. So there was really like this question mark about histidine that we couldn't solve in terms of what would be the recommendations, because recommendations were just so different between the different proposals that were coming from France or from different areas. And also, as Susanna mentioned, yeah, there might be something that was related to the type of study or the type of diet that the animals were being fed that was solved later on in the lab of Alex Richter. So that's why we focused our attention on histidine.
What are some major? Are there any good basal ingredients that provide histidine? Large amounts of histidine.
I think that what I've seen is histidine. Well, we used actually in one of the animal studies that I did at Penn State, we used blood meal, which has overall quite a good profile of different amino acids, and histidine especially is quite high. I think from common feeds fed on farms, histidine is not usually limiting if the metabolizable protein is adequate. Or higher levels, and it's very difficult to increase histidine per se from just feedstuffs. That what I've understood. So that I would say. I don't know if Helene has any input on that.
Well, maybe also just to mention that why also histidine became such a hot topic, if I could say so, is that because all the consumers' demand and all the emphasis that was put on reducing the footprint of dairy production, we want to work more and more with diets that are lower in terms of protein supply. And what we always learn at school that microbes had really a good profile of amino acid. But if we have a closer look, actually, the microbes, they have a low histidine concentrations compared to a lot of the feed ingredients. So when we try to reduce the protein content of the diet, usually we increase the proportion of microbial protein because we know that this is like a cheap, good source of protein to have like high microbial protein. But when we do so, then we decrease the supply of histidine at a higher rate than we decrease the supply of other amino acids. So basically, initially it was thought that it was with grass silage diets, for example, that histidine was being limiting. But then we realized that no, it's because when the grass silage diets were being fed, they were low protein diet. But if we feed low protein corn diets, we're facing the same situation. Really, if you look at the proportion of histidine relative to MP, as the crude protein concentration of the diet decreases, this proportion of histidine decreases. So if we want to work with low protein diet, then we'll have to put more attention on histidine, which we didn't have to do when we were feeding cows with like 18% crude protein diets. But if we want to go with lower supply, then we have to pay attention to histidine. And as Susanna was saying, blood meal is quite good, but it's not allowed in all the countries. And sometimes when we look at the canola meal, for example, it's not like a super ingredients compared to blood meal, but it might bring a little bit more histidine than other types of protein supplementation as well. So
yeah, and this is something we have also. I was involved in some studies we've done at Penn State comparing canola meal and soybean meals, and there we see the profile of histidine is slightly better in canola meal compared to soybean meal. Yeah. And I would add also to the point Helene was making about the low protein diets, and I think this is a lot of the work. Before I joined Dr. Ristov's group at Penn State, they already did quite a few studies with these low protein diets and supplying both methionine, lysine, and then later histidine. And this histidine work really came about because of the low metabolizable protein diets, and they were observing very low levels of plasma histidine, and that's kind of where this histidine came into play there. And I was very excited to join that line of research and kind of complete it with this meta-analysis. What came a full circle, I feel.
So, Susanna, how do you define a low protein diet? What does that mean?
Yes, this is a good question as well. I think we work really with looking at metabolizable protein deficiency. based on then NRC 2001, which now maybe Ellen can then explain more what's new in the current improved models. But we were really looking into metabolizable protein and then deficiency in terms of recommendations in the NRC, and we were basing it between around 10%, 5 to 15, I would say we were working with. And then the crude protein content, I think we had around 15% crude protein in those studies that I did at Penn State.
Yeah, so they're not rock bottom low. They're only like 5 or
Yes.
10% deficient based
Right.
on the old system. So they're not
Mm-hmm.
really, really low. They're quite I'd say reasonable diets in today's environment. So, and so with all this emphasis on blood meals limited in countries, and it may eventually become limited in the U.S. with low protein diets, it's the need for supplemental histidine is likely going to increase in the future, not decrease.
Right.
So I think this is very relevant to what's going on now. So if again at big picture, let's just start with production. What basically did you find with the effects of supplemental histidine on production measures?
So we really saw. So how we did the analysis was, first we looked at just overall effect of histidine, quite a more simplified approach to look at the effect size. And there we saw a clear response in production, so milk production, tri-matter intake, and milk true protein yield. And that milk true protein yield really was one of the parameters that responded quite really well to supplemental histidine, quite a clear effect there. And then we also did a regression analysis, so then looking at the increasing dose and how then the different variables responded to increasing histidine supply. And there also we saw positive effects on tri-matter intake, milk yield, and then milk true protein yield. So those were the major parameters that we had a positive response in. Milk fat is interesting. We've seen also in the animal studies that there is a slight decrease actually in milk fat concentration, especially. But milk fat yield, then usually there is no much effect there.
So on the milk protein yield, to me is you're providing more amino acids. On the intake, which wasn't big, but it was pretty consistent.
Yeah.
Is it because of the demand for more food for the higher milk production, or does histidine have a physiological effect on intake control?
Yeah, this is very interesting because it's been quite consistent, especially with the studies we've done at Penn State and with low protein diets. And it's very interesting because we don't really, that's kind of what we only can speculate for now, and maybe something to look into a bit more. If it's a pull effect, of the increased milk yield, or if, because there are some amino acids, including histidine, mostly in more like monogastric models, that have been shown some possible signaling effect that histidine would have on the brain. But this is still quite speculative, and we don't have really clear evidence on that in dairy cows. But it's a very interesting effect that hasn't been really shown with other amino acids, as far as I know.
And like I said, it was very consistent across all these studies. So.
Mm-hmm.
Yeah, well, actually, it's too bad because when we were doing the studies with Alex and the initial studies where we fed rumen-protected histidine, we put a grant proposal to have a look at the mechanism of actions, but that never got accepted. But that was, as you said, it's very consistent, and it really seems to be there. So is it a pull from the increased milk protein yield, or is it something which has, I don't know, is histidine acting on the appetite control? So that would have been nice to get the measurement. And just to add to what Susanna said, and then I'll come back to the NASEM, is really one of the reasons why actually I think we saw an effect when we fed increased or when we infuse histidine, when we had higher supply of histidine, is that in the initial treatment or in the control treatment, actually, when we look at the efficiency of utilization of histidine, that we can calculate with the NASEM now, but that basically it is like the total outputs of protein times their amino acid concentration. So it's going to be milk, metabolic fecal protein mainly, and growth if there is any growth. And we divide by the supply. When this efficiency actually is too high, the calculated efficiency, it means that we're asking the cow to use the supply that we're giving at like an 85 or 100%. And actually, when we look at the tables that Susanna made, um, we see that in the infusion type of studies or in the deletion type of studies, the actual efficiency of the utilization of histidine was above 100%, which means that in theory, we were asking the cow to be using the supply of histidine above 100% of efficiency, which is not biologically possible. Either the cow is using its body reserve, it has some labile pool of histidine as well. So obviously, when we gave extra histidine, then the cow was making more milk because then she was able to, well, she had sufficient supply of this amino acid to increase its protein output. And at the same time, what it did is that it increased the efficiency of utilization of the other amino acids. But the other way around, sometimes when we look at what did happen is that if we're feeding a cow a supply, an extra supply of histidine, but the cow is already using, because of the diet that she's being fed, methionine at an efficiency of more than 100%, the cow will not respond to histidine because she has to use, she's already chopped in terms of reproduction by the supply of the other amino acids. So we really have to look at all the amino acid one relative to each other. And I think that, this concept of efficiency needs to be refined in terms of, what's the exportation and how they are affected by dry matter intake, for example, or by protein supply. But with the knowledge that we have now, we know that we cannot ask an animal to be efficient at more than 100%. If she does so, it's because she's taking on her body reserves. So I think that it's quite clear in the graphs and in the stats that Susanna did, that when the cows were underfed, with an efficiency of utilization above 100%, which was basically the infusion study and the deletion study, the milk protein response was much greater than when the cows were receiving a diet that was supplemented, because then with just a diet, we cannot decrease the relative supply of histidine as much as we can when we do a deletion study or an infusion study. So we really have to look at this ratio, I think, which is quite important.
Are the responses to supplemental histidine, are they pretty immediate, or is there a lag effect before you see a response in the cows?
So I think for us, with the regression analysis, we did see. I mean, it was like a log logistic model that we used because of this kind of a curvilinear response, where at lower levels there is a bit of a lag before we see the response, and then it kind of plateaus after the maximum is reached. But this is also what Ellen kind of plays into what Ellen was saying also, especially for the milk true protein yield, where we really had a very low supply of histidine from the basal diet already with the infusion studies and especially the deletion studies. And there I think that's kind of where we start. It's a more a gradual response, but then once we hit the dose starts to increase, then the response also is much greater when we are especially infusing the histidine. And then one point to make also with the rumen-protected histidine, the studies already the basal diet was supplying more histidine that compared to the infusion study. So there the response is also a bit not as great as we approach higher doses of histidine. And there maybe this is a time to bring up the bioavailability also, which is can muddy a little bit or why we also saw the differential responses in between the different histidine types, the supplementation methods for the true protein yield and also plasma histidine when we looked at that. And there may be there is some overestimation of some of the products that were used in different studies, and then the actual dose maybe was lower, and the response was a bit underestimated in relation to the dose
for the RP products.
Yes.
One thing that on all these graphs, and I know there's effects of method of supplementation, but almost everything plateaued around 60 grams of methionine, except plasma. That kept going. It was linear. Everything else plateaued. That didn't make sense to me, because I was expecting, if it's plateauing, it just, that relationship, or that different relationship, didn't make sense. Could you make it make sense to me, please?
I think maybe this is also, we can bring in again the efficiency of utilization. And this was also for the efficiency of utilization, we kind of hit the optimal efficiency at the 60 grams per day, more or less. And I think that has to do with what we also saw in the production parameters. And here we separated, there was also differential response depending on the metabolizable protein supply. So actually with lower protein diet, the optimal supply in relation to the efficiency of utilization was actually higher. So at lower protein supply, then the cow needs more histidine supplied, because what we talked about, the microbial protein there, the ratio or amount of histidine supply then is lower. And that's why, so for the lower protein diets, we would need more histidine.
So
Yeah.
Because again, the plasma concentrations didn't mimic the production responses or the profile. So can we use, does plasma amino acids have value in like developing diets and supplementation strategies? Or
This is maybe Ellen wants to talk about the liver extraction at this point, or
Yeah, but I think that the first point, maybe Bill, would be that actually it's when we look at the graphs, when we put all the studies together, there's not that many studies where we had a dose response, right? So most of the time we just have like a control and so it's much harder then to try to get a plateau response. But in like the two last studies that we did that were deletion studies, we could really see that at high supply we reach a plateau of concentrations which was going in the same way as the plateau in production. And again, just as Susanna opened the door, which is quite interesting for us, is that when we look at the efficiency of utilization, and if we look at the contrast, which would be the inefficiency of utilization of histidine, for example, when we had made measurements of liver removal of histidine, they matched quite nicely, which meant that the inefficiency actually was quantitatively pretty much the same as the quantity that the liver was being removing. So the more we give, actually, the more the liver will be removing. And when we get to really high supply, then this is why actually the concentrations will plateau, because once the cow doesn't have anything to do with the histidine, well, just to avoid any toxic effect of hyper amino acid concentrations, then the liver will just pump out all of the histidine, as it will do for methionine, for example. There's a group of amino acids which are really removed by the liver, and this inefficiency, which was quite nice, for our calculation, the calculated efficiency or the calculated inefficiency that can be inputted by nutritionists using NASEM, for example, really matched quite nicely the liver removals, which means that it is not just like a theoretical concept to amuse scientists, but it's really a concept that can be used on the farms. And that would be one way, for example, to examine the diet to see if it can be responsive or if histidine is limiting or not in this type of diet, would be to look at the efficiency. I'm always coming back to that because for me it's really the main message, and I think this is something that can be really applied on the farms, is that if you look at the efficiency And if we had a target efficiency of about 75%, I think, in NASEM. If we're running at an efficiency of 85 or 90%, it really means that the cows are missing some histidine. But if we're below 70%, then histidine is not the amino acid to target. There's other things to add. But within a single study, to come back to your question, if I come back, within a single study, if we have like a lot of dose that we infuse at the high doses, we're seeing a plateau in the concentrations, which are matched by increased liver removal.
And I want to ask this question, and that is on the relationship between energy and histidine. You did energy intake, is not megacalories per kilogram, but megacalories per day. And a lot of that variation is actually, dry matter intake is a major source of the variation in net energy supply. So do you think if you fix dry matter intake, so intake of all the nutrients are the same except energy, do you think you'd still see what you were seeing, or because again, as net energy intake increases, intake of everything is increasing, not just energy, or usually. There's not a lot of variation in the concentration of energy. There's a lot of variation in the intake of energy, though.
Mm-hmm.
And I'm just wondering, is it energy, or is it just nutrients or dry matter?
Yeah, this we only did so we calculated the histidine supply per net energy for lactation supply, and this was then we looked at the effect of that on the efficiency of utilization. So there then we got a very nice response showing the relationship of or the optimization of both histidine and energy supply. And I think Helene, also this is in the new NASEM also we have this effect of energy on the utilization efficiency. So
I've got a few questions. So the first one is, what do we think the requirement is for histidine in a lactating diet?
Well, I'm biased because I've been working on that, but I think we should target an efficiency of utilization of 75% with a correct energy supply, because as Susanna mentioned, and it has been shown by many studies actually, the efficiency of utilization of the amino acid will be affected by the energy supply. But if we have a correct energy supply, I think we need to look at how much milk we want our cow to produce, how much protein, then do the calculations, then fit the 75% efficiency, just divide, and that will give us a supply. So it's not like I don't think we can just go with the magic number. It's easier. It's much easier to go with like X percent, but I think that as the milk production will vary and the dry matter intake will vary, then the outputs in terms of metabolic fecal output, which is quite important in milk, the proportion of one relative to each other does vary as well. That will affect the absolute amount of histidine we need. So it's not as easy because we need to go through the calculations, but I think that targeting like 75% efficiency for now, maybe after we'll have done a little bit more studies or more application on the field, on the farms, we will be able to fine tune this number. But I think that for now it seems reasonable.
And I would also add what we also saw in the meta-analysis, that this depends also on the overall protein, for example, protein supply, if we talk about metabolizable protein or energy. So it's hard to give one number. And I also agree that this efficiency of utilization is a nice target, because then you can adjust then the absolute supply as grams per day, for example, based on the other variables in the diet as well.
But obviously, if you reach that target for histidine, but if you're above target, or if you're just not supplying another amino acid in a sufficient quantity, then you do not allow the cow to express full utilization of this amino acid. So everything really needs to be looked at in relation in a global scheme. You cannot just like pinpoint one amino acid and say, okay, I'm going to feed that one and I'm clear. You really need to look at all of the amino acids because they're all important, right?
Yes.
It depends on how much we find in the feed ingredients that is changing our perspective. But actually, for the cow, they are all important.
So, what are some practical implications of the histidine work and the meta-analysis? Are there some things that can be applied in the field today?
Well, I think as we just mentioned about the way the diets are formulated, I think especially in terms of looking at the total protein content of the diet, if this is something a farmer wants to decrease for different reasons, which I think will be increasingly so. Then I think histidine and this efficiency of utilization should be taken into account and see how those diets can be formulated. And currently, unfortunately, we don't have the rumen-protected histidine available, but hopefully this is something, if as we also saw in the meta-analysis that histidine is important and increasingly so, I think that's another point, I would say.
Yeah, and I would say that the meta-analysis also clearly shows that if we are not supplying enough histidine, there is really a penalty in terms of milk yield, in terms of dry matter intake, in terms of milk protein yield. So really, this is something that we need to take into account. And also one point, which is not in the paper per se, but in the supplemental material, is the marginal recovery that Susanna has been talking about, which is like from the extra histidine you supply, how much actually you will find back into milk. And on average, I think it was around 20%, which is much higher than what is usually seen for the rumen-protected methionine, which is more about around 7%. So there's really options actually to make sure that we do have enough histidine. And if we do not have enough histidine, there is a penalty that our cows will be paying. So, and there's a way actually to check if the cows are receiving sufficient histidine.
So, Susanna, you mentioned early on in our discussion today that in the infusion treatments there were different sources of histidine utilized. Did I hear that correctly?
So the infusion studies, they were different types of infusions. So
Oh,
we
different
had,
types of infusions. Okay.
yes, not so the histidine that was supplied was all studies used L-histidine. Yeah.
Kind of related to that, I think you also said that the infused histidine studies were done mostly with cattle on grass, and the rumen-protected histidine was done with cows on silage. Was that because of where those studies were done, or just looking for some background on that?
Yes, so the early work with histidine was mostly done in Europe, in Finland. Actually, my previous professor I worked under Aila Vanhatalo at the University of Helsinki, and her colleagues, they did some infusion studies on grass silage-based diets, and then in the UK they also conducted some studies with different infusions of histidine. And then Helene did also these deletion studies, but she used corn silage-based diet. So those are the exceptions of the infusion category, I would say.
Very well. I guess another question I have is, we typically talk about lysine, methionine, histidine being the most limiting amino acids. So what would be next after those three?
Well, in the meta-analysis, we were also looking at the efficiency of utilization of other amino acids and how that would affect the efficiency of histidine utilization. And one that in addition to lysine and methionine, we saw leucine was also there, having an impact. But otherwise, I know in the new NASEM there are also other amino acids included that maybe require some future work as well to see the full profile of his not histidine but amino acids and how those play and what are the optimal supplies and how we can reach the optimal efficiency for the group of amino acids. I don't know if Ellen has
Well,
any.
yeah, well,
Anything
actually, I would
with that.
just answer it really depends what you feed the cows, right?
Yeah, great
So
point.
if you feed a cow with a lot of corn, for example, you won't be short in leucine. But if you don't feed any corn, then leucine you might become short of. So it really depends. I think that this is sometimes what we hear is that the cow is like, this diet is limiting for the cow. Actually, this is really depending of what's being into the diet. There is not this diet, but this amino acid is limiting for the cow. There's not an amino acid which is limiting for the cow. It depends of the diet which is being fed, and I think this is really something that we need to keep in mind. It depends so much of what's being fed. So as Susanna was saying before, for example, feather meal we know is really, really, really low in histidine. So then if you feed that, that's for sure that histidine will be on the ground. And yeah, and I think probably it's a major difference sometimes between Europe and United States, where in Europe they will feed less corn, and I think that in some cases they've shown that leucine might it will be worth it to have a look at leucine, for example. Whereas if you have plenty of corn, well, you will have a look at it, but the chances that it is limiting, that it's going to be in short supply. I think I prefer to say in short supply than saying limiting, will decrease. So it depends so much what are the feed ingredients.
Any other questions for you?
No.
I got one last question. I'm kind of curious about, what's the next steps for histidine? As Bill had mentioned, he anticipates that it's going to be more and more important as we begin to feed cows a little differently. So what's some of the next steps relative to research?
Yeah, so for me, I really, really do want to continue the work I've been doing on histidine. So, and I think we didn't touch too much on it today, but the liable histidine sources, the endogenous histidine sources that we have in hemoglobin, for example, and different muscle dipeptides that can be mobilized during histidine deficiency. And this is something we have seen in some studies, but require long-term investigations. This is something I would like to look into. And in general, I think long-term studies would be interesting to see. And then different lactation stages of the cows as well. Transition cows are quite challenging to study, but I would say histidine would be interesting amino acid to look into there as well. I know there has been a lot of work on methionine, but I would think histidine is also important in that stage of lactation. And then I think also this energy histidine interactions is something also interesting to continue working on, as we saw a very strong relationship there as well in the meta-analysis.
So Susanna, it is the reason why blood meal is such a good source of histidine is because it's high in hemoglobin.
Probably yes. I actually haven't thought about it too much, but now that you say it makes total sense. Yes.
Yeah. As Susanna was saying, is that this is something that we see if the cows are being short in histidine, for example, their hemoglobin level will slightly decrease. So that will offer the cow like an endogenous source of histidine. There are some dipeptides as well, like carnosine, that will be replaced by another type of peptides that will have the same buffer function in the muscle, but so that can mask actually the histidine deficiency. And actually in human nutrition, it has been quite a challenge to define what would be the histidine requirements because of that. Because if you take a human being and if you put it on a diet which is short or with no, because we can do artificial diets, it's tough we won't see very quickly the histidine deficiency because of the use of all these internal sources. So the same thing will happen with a cow, but the cow is pumping so much milk out, then the deficiency occurs much quicker.
Tonight's last call question is brought to you by NitroSure Precision Release Nitrogen. NitroSure delivers a complete TMR for the rumen microbiome, helping you feed the microbes that feed your cows. To learn more about maximizing microbial protein output while reducing your carbon footprint, visit balchem.com/nitrosure.
Bill, if you will, can you give us kind of a few takeaway thoughts regarding what we heard today?
Well, One is, meta-analysis are powerful statistical tools. They do have limitations, but they are powerful tools. And with this analysis, they show all the results by treatments or by experiments, so you can see the consistency. And they also did some other things to look how important, if it's one study is biasing the results. And so I think this is a good analysis. It shows clearly histidine's important. And again, with the discussion they have in the table, in the text, it's going to become more important. With the way we're going to change formulations, it's going to become more important. So I think it's a very well done meta-analysis, and I think it has a lot of practical importance.
Helene, one last question for you. Our audience consists of a lot of consulting nutritionists out there building diets every day for their dairy farmers. What's a couple key takeaways from the meta-analysis that you think that the consulting nutritionists out there ought to take away from this discussion?
I think the major point actually is, as I mentioned before, is that histidine needs to be taken seriously. If you don't supply enough of it, then you'll have a penalty on your cow production. So I think this is really, for me, the main message which is coming out of that. And again, the efficiency of utilization will be affected by the energy supply as well. And we have tools actually with the NASEM to look at this efficiency. And we can assess actually if the herd is or the cows are receiving sufficiently of histidine, but also the other amino acid. But again, what the meta-analysis clearly showed is that if there is not enough histidine in the diet, if the cow does not receive enough histidine, there's a penalty on milk yield, milk protein yield, and also it might have an effect on dry matter intake, which is also like a vicious circle. So I think the message is really clear on those three main points for nutritionists.
All right, very well. Thank you for that. And Susanna, any final words you'd like to leave with the audience?
Yes, I think I 100% agree with Ellen. I would like people to remember that histidine is important. And if there is anyone out there wanting to produce rumen-protected histidine, this is also a important message for me as I want to continue this line of research into the future.
All right, perfect. Thank you for that. I think it's pretty unanimous. All of our guests says that histidine's important. So I'm going to surmise that we're going to have additional conversations, be they podcasts or webinars on this subject. So I would ask our audience to stay tuned. With that, I want to thank you guys for joining us today. This has been a great discussion. I've enjoyed it. Looking forward to the next one. To our loyal audience, thanks for joining us once again. We hope you learned something. We hope you had some fun, and we hope to see you next time here at the Real Science Exchange, where it's always happy hour and you're always among friends.
We'd love to hear your comments or ideas for topics and guests, so please reach out via email to anh.marketing@balchem.com with any suggestions, and we'll work hard to add them to the schedule. Don't forget to leave a 5-star rating on your way out. You can request your Real Science Exchange t-shirt in just a few easy steps. Just like or subscribe to the Real Science Exchange and send us a screenshot along with your address and t-shirt size to anh.marketing@balchem.com. Balchem's Real Science Lecture Series of webinars continues with ruminant-focused topics on the first Tuesday of every month, monogastric-focused topics on the second Tuesday of each month, and quarterly topics for the companion animal segment. Visit balchem.com/realscience to see the latest schedule and to register for upcoming webinars.